Hi everyone, today we are going to order and compare fractions by using models and an understanding of the concept of numerator and denominator. Up in the corner I have the fraction 1/4. I've reminded you that numerator means the number on top, denominator is the number on the bottom of the fraction. Also, I have some pictures of some fraction cards down here. Each card has some blue in it and some white in it, and then it has a fraction. So we have the fraction 1/2 right here, and then we have 1/3, we have 1/4, we have 1/5, and finally we have 1/6. I want you to take just a minute to think about this question. What happens when the denominator, number on the bottom, gets bigger? All right, when the denominator gets bigger, the amount of blue, the size of each section, the amount of blue gets smaller. And that's because you have to fit so many of the sections into the same size space. For the fraction 1/2, we have to just divide the card right here into two pieces. And then I would shade one of those two pieces blue. So each piece is really big because there's only two sections in the card. When I look at 1/3, I have to divide 1/3 into three sections. That's what the bottom number tells me. The top number tells me I just need to shade one. So now, because I have three equal sections in the same size card, each space gets a little bit smaller. But when the number on the bottom, the denominator of the fraction, gets bigger and bigger and bigger, the size of each piece is smaller. So when you have a really big number for your denominator and the numerator is 1, then that means your fraction is really small. 1/2 is a much larger amount of space than, for example, 1/6 is really small. Look, these cards have exactly half shaded. Here we have 1/2, half the card is blue. Here we have 4/8 and half the card is blue. Next one, 2/4, half the card is blue. And 5/10, half the card is blue. I want you to also notice that the top number, in this case 4, it's half of the bottom number. Okay, so therefore this fraction is equal to 1/2. This one, 2, is half of 4. Here we have 5, which is half of 10. Can you think what would be half of 12? Yep, the answer would be 6. So 6/12 would be another fraction that would be equal to 1/2. Which brings me to my next slide. This is called equivalent fractions. Equivalent fractions are fractions that name the same part of a space. 1/2 is equivalent or equal to 4/8, 2/4, and 5/10. There's a chart down below. Let's move it up a little bit so you can see it, and we can record our work. So I can write down fractions that are equal to 1/2 down here. If I want to figure out what's equal to 1/2, here I have space to just list them. So we already did the work. We're just going to record it now on paper. So a fraction that would be equal to 1/2 would be 4/8. I would also have 2/4 is equal to 1/2. I would have 5/10 equal to 1/2. How many 14ths would be equal to 1/2? Think of the last slide. What's half of 14? Have you figured it out yet? Because I'm ready for your answer. It is 7. So 7/14 would be another one. And I could go on and on and on with these fractions. So all of these fractions I've written in this space are equivalent or equal to my starting fraction right here of 1/2. Another way to think about this is to use something called a fraction bar. We did some paper folding with fractions and number lines in our work in class, and this is very similar to that. So we see at the top I have one whole bar and it is colored blue. Okay, I can look down below. In my next bar that's red, I have 1/2 and I have 1/2. 2 halves would be equal to 1 whole bar because it takes 2 of them to make that same amount of space. I can look at fourths. I have 1/4, 2/4, 3/4, and 4/4. All 4 of these fourths would be equal to 1 because it takes 4 of these bars, these size bars right here, takes 4 of them to take up the same amount of space that you see up here with 1. How many fourths would equal 1/2? Let's take a look. Here's our 1/2 bar right there. And I want to know how many of these fourths right here, how many of those would it take to make the same amount of space that 1/2 takes up? Looking for an equivalent fraction to 1/2. Yep, that's right. It's 2/4. I would have 1 here and 1 here. And if I circle 2 of these, you'll see it takes the same amount of space that 1/2 does. So 2/4, 2 of these, 1 and 2, would be equivalent to 1/2. All right, I want to talk to you about a game now. There's a game called an equivalent fractions game, and if you have fraction cards, you can play this game. So I want to go through the rules with you. The goal is to collect fractions that are equal to each other. So we want to collect a whole bunch of fractions. The way I win is getting the most cards. And what you have is a deck of cards right here, and then you have a starting fraction. So in this case, 1/2. When it's my turn, I want to draw from the deck of cards, and I want to draw a fraction, and I'm hoping that it's equal to 1/2. So let's see what I get. All right, the first fraction I've drawn is 2/3. I'm going to lay it right next to 1/2, and I want to make sure that I line up my cards so the bottoms are even. If I put it up here, I'm not really comparing the same amount of space. I want to put it right down here and make sure the bottoms are even. And now what I want to do is look at the amount of blue. 2/3, that's a pretty big fraction. Most of the card is blue. 1/2 is smaller. You can see that this amount of space is smaller. So this means they are not equivalent. My turn would be over. Now it would be my partner's turn. I'm going to just leave the card here, and my partner's going to flip a card. Pretend this one was upside down and now it's flipped over. This one is 4/8. So I want to compare 4/8 and see if it equals either of these cards. Well, we can see 4/8 is smaller than 2/3. There's less amount of blue. Let's see if it's equal to 1/2. Maybe I can take that card. And yep, the exact same amount of blue, plus I know that 4 is half of 8, which is equal to 1/2. This means I get to take both cards. So our goal is to keep flipping over cards, and if we get a match, we take the cards. If there's no match, then our turn is over. I want to talk to you about one more thing today, and this is comparing cards that are not equal to 1/2. We can also compare fractions using less than, greater than signs. So here we have the fraction 1/4, and we can see that it is not equal to 1/2. Way less blue is shaded. So 1/4 is less than 1/2. Here's some more fractions that are less than 1/2. 2/10 is less than 1/2. 3/9 is less than 1/2. And 0/4, of course, there's nothing shaded there. That's less than 1/2. So I want us to think about the numerators and denominators of these cards. And I want you to think, is there a pattern that could help you besides looking at the amount of blue if it's more or less than 1/2? Take a minute to look at those cards. Okay, let's talk about this. So 10, if it were equal to 1/2, I'm looking at the denominator of 10. If it were equal to 1/2, then it would need to be 5 out of 10, right? 5/10 would be 1/2. Now when I look at the numerator, well, let me back up a second and write that down. So if this 10ths card was equal to 1/2, it would be 5/10. I want you to notice that the number on top right here, this is a 2. And 2 is less than 5. It's smaller than 5. So that means this card is less than half. That's another trick you can use. We can do this with fractions that are more than half too. So here's an example. 4/5 is greater than, using our less than, greater than symbols, greater than 1/2. Okay, if we go down below, thinking again about the numerators and denominators, okay, we want to figure out, what do we notice? Well, half of 2, in this case we know it's more than 1/2 because the whole thing's shaded. But if we were to think of our little trick, half of 2 would be 1, right? So 1/2 would be written as 1 over 2. And if we look now at the numerator, it's a 2, and that's more than 1. So that tells us this is more than 1/2 shaded. Okay, today you learned about equivalent fractions.